All right, pencils down. So that was 15 minutes. Hopefully this is one that you find you got a lot of things right on. I thought this was pretty straightforward. So let's see what we got. Let's grade it like it's a free response. So let's try to put some points to this. So yeah, it's going to be hard here. I don't know. Yeah, there's some justifies. Yeah, okay. All right, so for part A, average rate of change. Average rate of change means to find the slope. So for 0 to pi, you should be thinking of it like that, right? 0 comma something, pi comma something. And what do we want to do with the somethings? We want to plug it in. So if you plug in 0 to the original, that's going to be e to the 0, which is 1, times cosine of 0, which is also 1, and 1 times 1 is 1. Next, for pi, if we plug pi in, that's going to be e to the pi, and cosine of pi is negative 1. So that's going to be negative e to the pi. Pretty bizarre answer coming. Both go with it. So the slope is going to be negative e to the pi minus 1 over pi minus 0, which is pi. And that is our average rate of change. Does anybody have any questions on letter A? Okay. Letter B, what is the slope of the line tangent to the graph at x is equal to 3 pi over 2? Angie, you there? How about Sarah?
Yeah, so for this one, I made the box and did like the point and then m prime
So our,
the tangent line.
So our point is 3 pi over 2, comma, what do we get when we plug that in?
I got 0, I think, because cosine of 3 pi over 2 is 0.
Sounds good. All right, and what are we doing for a derivative?
I did a product rule for this one.
So what's that give us?
I got the equation.
No, it's just the derivative.
So I got e of x times negative sine x plus cosine x times e to the x, I think.
All right, and into that derivative, what are we plugging in?
3 pi over 2.
Okay, so that's gonna be what?
For this, I got e to the 3 pi over 2, but I'm not sure if that's right.
All right, let's plug in and see what we got. So that's e to the 3 pi over 2. Sine of 3 pi over 2 is negative 1, but negative makes that a positive. Cosine of 3 pi over 2, that's going to be 0. Doesn't even matter anymore. 0 times anything is 0. So I would agree that we've got e raised to the 3 pi over 2. And it did not ask us for the equation of the tangent line, just wanted the slope of the tangent line. So now, some things to note here, guys. On the AP exam, College Board is not going to recognize this cute little box we've been doing all year. And even though it's helpful, we need to make sure we are documenting what's what here. So over here, we need to make sure we put that f prime is equal to f prime is equal to, or I'm sorry, this one right here shouldn't have said that. That should say, for this one right here, it should say f prime of e to the 3 pi over 2 is equal to that. So we want to make sure we are explaining what's what here. Here's my derivative. Here's the derivative with e to the, or my, I was just plugging in 3 pi over 2. Sorry, I'm losing my mind there. So this is the derivative with 3 pi over 2 plugged in. And then you want to show that that gives you e to the 3 pi over 2. So the box is just helpful for organizing. But again, you still want to label what you're doing. We're going to label F prime of 3 pi over 2, and so on. Does that make sense? Does anyone have any questions?
How did we get 0 again? Just checking. I think I missed it.
How do we get 0 for the
The
corresponding
value.
the point? We would plug in 3 pi over 2 to the original. So if we plug in 3 pi over 2 up here to the original, that's e to the 3 pi over 2 times cosine of 3 pi over 2. Cosine of 270, that's going to be 0.
Okay, yeah, I was just checking if I did it correctly.
Okay. Any other questions on part B? Okay, part C. Part C. Jason, you there?
Yeah.
What are we thinking?
So it's absolute extrema. So it's the original, and you put in the endpoints and the critical points.
All right, what are my endpoints? 0 and 2 pi. All right, now, how do we find the critical points?
You take the derivative and set it equal to 0.
Okay, now, we already found the derivative in part B, so let's just pause for a second here, and I'm actually going to turn the screen share off so we can see this a little better. So, what are we doing here? We're taking this derivative, which is e to the x negative sine x plus cosine x e to the x, and we're setting it equal to 0. All right, how'd you go about solving this, Jason?
I combined them and then I factored out an e to the x.
Yeah, exactly. So we want to factor out e to the x. And if we factor out e to the x, it's going to leave us negative sine x plus cosine x is equal to 0. All right, so if you remember earlier in the year, we said you cannot set e to the x equal to 0. So you get to just cross that out. And then we set this last piece equal to 0. So negative sine x plus cos x is equal to 0. If you want, you could stop right there and ask where is. I think it's easier to do this. Cosine x equals sine x. In other words, toss that to the other side. And now when you ask where is cosine x equal to sine x, what'd you get for answers there, Jason?
Pi over 4 and 5 pi over 4.
Correct. So those are the critical points we're going to toss on here at pi over 4 and 5 pi over 4. All right, so endpoints and critical points get plugged into the original. Okay, the original is e to the x cosine x. So some of these we already have from up above. If you plug in 0, that gives us 1. 2 pi is the same thing as 0, so that ought to give us the same answer, hopefully. So if you put 2 pi in, how's that going to change things? That's just going to be e to the 2 pi. Well, actually, it does change things, I guess, because it's going to be e to the 2 pi, and then cosine of 2 pi is still going to be 1. So we'll call this one e raised to the 2 pi. All right, what happens now at pi over 4? That's going to be e to the pi over 4 times root 2 over 2. And the other one's going to be e to the 5 pi over 4, endpoints, critical points into the original, e to the 5 pi over 4. And then that one's going to be times negative root 2 over 2. What in the world are we looking for here? We're looking for what kind of value?
The smallest y, so it's 5 pi over 4.
Yeah, exactly. So keep an eye on what they're asking, because I don't know what any of this stands for. I mean, I know what 1 is, but I don't know what any of this is. But since I'm looking for the smallest value, I can say, oh, well, that's negative. These 3 are positive, so that's the smallest one. So it's an absolute min at y equals that mess, negative root 2 over 2 e to the 5 pi over 4 when x equals 5 pi over 4. So we don't really know what the actual numerical answer is, but we can do some reasoning to figure out their question. Do we have any questions there?
Is that all the justification you need? It says justify.
Yep, as long as you show your table with endpoints, critical points, and make a final statement, you are good to go.
Okay.
All right, last one, part D. Isabel, you out there?
Yeah.
All right, what's up? What are we doing?
So I actually wasn't really sure about this one. I got confused.
You got confused? All right.
Yeah.
What's the first thing we always try to do with a limit problem?
You would test it by each of the rules. So
All right, so what's the first rule we try? Like day one calculus. What's the first thing I was hoping? What's the first thing I hope I can do? With my limit problem, I hope I can do what? Take the value and
plug it in.
yeah, I hope that I can do that. So what happens if we take the value and plug it in? That would be f of pi over 2 g of pi over 2, right?
Mm-hmm.
All right, what happens when I do that? What's f of pi over 2?
That would be 2.
What?
Oh, wait, sorry. I was looking at the graph, my bad.
Yeah, f's the function up top, g prime is the function on the bottom.
So then that's just 0.
Okay. What do we know about g of pi over 2?
That would be also 0.
Because they tell you that in the problem, right?
It gives it to you.
Okay. What do we do with limit problems that when you plug in, you get 0 over 0? What are we doing with that?
Isn't it L'Hopital's rule or something?
All right. So how's L'Hopital's rule work?
You would take the top, I believe, and then you set it to 0.
Try again. L'Hopital's rule says to take the limit you had and do what? Take the what? Take the what of the top and the what of the bottom.
The derivative.
Okay, so the derivative of f of x, f prime of x, and the derivative of g of x, g prime of x. So now this is the limit as x approaches pi over 2, f prime over g prime. So let's try it again. What is f prime of pi over 2? I don't know, but we know what f prime is, right?
Mm-hmm.
So I'm just switching paper here real quick. Let's plug in pi over 2, Isabel. What would that give us?
That'd be e pi over 2, and then negative sine pi over 2.
Which is going to be 1, then negative sine of it. Okay, keep going.
And then you'd have cosine pi over 2, which is 0, and then you'd have e over pi over 2. So that just cancel out.
Okay, so we're good. That'd be a negative e to the power, negative e raised to the pi over 2. So negative e to the pi over 2 over. All right, what do we got for g prime of pi over 2?
So then that would be 2.
Yep. You're done. That's your answer. They would give you full credit for that. If you want, you could call it this. That's the same thing as saying negative 1/2 e to the pi over 2. Doesn't matter though. Those are the same exact thing. Make sense?
Yeah.
Can you explain again, just when you first started, how you got g of pi over 2? Because it was the graph of g prime of x.
They tell me right here, read part D. Let g be a differentiable function such that, and then they tell us.
Perfect. Thank you.
Yep. So yeah, anytime you're looking for something and you're looking and looking and looking and you just can't figure it out, odds are good. It's just sitting right there. And it's just, they told you somewhere. So if you're looking for, because if you're looking for like past the point of 60 seconds and you don't have a plan yet, just pause and reread the part of the problem you're on and the opening paragraph they give you. Good chance it's just sitting there. Any questions, guys? A, B, C, D.
Did this question appear on the AP exams?
I think this is like identical to what you could see on an AP exam. I don't know that this one was on one. This was released from College Board in 2020 as a study guide question. But I think that's
Okay,
a
'cause it makes a lot of
pretty,
sense, yeah.
yeah, I think it's a pretty fair question. So that's my goal here. I'm picking things out that I think give you guys a pretty good chance. But yeah, these are all released from College Board, so it's not like I'm making them up. All right, guys, I think that's good for tonight. It takes us to about 40 minutes. Today's Tuesday, so we still got Wednesday, Thursday. I will be leaving you with a practice thing over the weekend. It is going to be a free response question that is like 12 parts long, I think. It's like A, B, C, D, E, F, G, H, I, J. There's like part M or N or something. I don't know. It'll probably take you 60 minutes to work through. So we'll meet again Wednesday and Thursday to keep doing stuff. And then I'll give you probably about an hour long free response question for the weekend. And we'll keep going from there. So good job. I will talk to you guys tomorrow.
Thank you.
Got it.
Thank
See ya.
you.